Okay, let's talk about how to add and subtract rational expressions. First of all, this is an expression because it doesn't have an equal sign, and we will simplify it. We aren't solving it. We only solve equations. Also, I would highly recommend that you go watch my video in the other helpful materials section about a review of fractions that might help you. Also, once you've watched this, before you actually do any of the practice problems, go watch my 3 videos in how to solve rational equations. Okay, there's 3 of them in there. It really would be a great idea for you to watch all 4 of these before you do these 2 sections. It will help you a lot. Okay, so this is just a fraction, but it does not, that I need to subtract from each other, but it does not have common denominators. So I have to get a common denominator. Also, if you guys have not read my document on how to build an LCD or an LCM, go read that as well. It will really make a huge difference. So the first thing I need to do here is factor both denominators, only the denominators. I can't factor these numerators, but even if I could, I don't want to now. I just need to work with the denominators. This is rule 3a because that's a 1 coefficient. And it's 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. So it's going to be 3 and 8. Needs to be a plus 3 and a minus 8. When I add these two together, I get -5, which is exactly what I want. And then positive times a negative is a negative, and that's what this is before the 24. So, very good. Plus 3, minus 8. Now let's factor the second one. And I get A and A. Now I've got 16. So 1 and 16, 2 and 8, 4 and 4. Looks like this one has to be -2 and -8. When I add these two together, I get -10. Negative times a negative is a positive. So there we go. All right, now I'm going to build my LCD. And we use LCD with expressions because we keep the denominator. So LCD for expressions. And we keep the denominator. Okay? All right. So when I am looking at this stuff, okay, I'm only looking at denominators to build my LCD. And I want to take whatever is in the first one. No matter what it is, I just take however little there is or however much or many of them there are, whatever they are, I just take it. Okay? And now I pretend that the first one doesn't exist, and I'm just going to look at the second one. First, I'm going to look at, I'm going to look at the first factor. So I look and see A minus 2. Is there an A, the quantity A minus 2 in my LCD yet? In my building, which I'm building, okay? The A plus 3 and A minus 8 is my foundation of my building. So I'm thinking about building this LCD building. Well, I do not have an A minus 2 yet, the quantity. So I need to include, say include or multiply. If you say add, I guarantee you're going to put a plus there and it will mess you all up. So say I need to include it or add it. Include it or multiply it. Don't do what I just did. Okay, and now I'm going to look at this next one, the quantity A minus 8. And look at that, that's already here. So I am done. This is my LCD. Okay? So now I am going to write down my first, write the denominator in factored form, always. Okay, I'm going to write down my first term exactly like it is. And then I'm going to say, okay, what do I need to multiply with the a plus 3 times the a minus 8 to get everything in my LCD? Well, that would be a minus 2. If I do that in the denominator, then I need to do it in the numerator as well. Oops, excuse me. And I just realized, and I hope somebody caught it, that when I wrote this down, I didn't write 4a. Okay, now I'm going to write down my second term exactly like it is. I also need to remember that this negative eventually will have to go to everything behind it. Remember that, because so often students will put it to the 2a but forget to put it to the 3. Okay, and now this is a minus 2 in this denominator and a minus 8. Okay, and now I'm going to look and see, what do I need to multiply with the a minus 2 and a minus 8 to get all of this in my LCD? Well, that is a plus 3. But if I do that in my denominator, I need to do it in my numerator. Okay, so now I know I've got the same denominator in both terms. So a plus 3, a minus 8, a minus 2. So I just need to write that down. And now I just need to take care of the numerator. So I'm going to distribute this to both of these. So that's 4a squared minus 8a. Now I'm going to be very, very careful with this next stuff, because this is a minus and it has to go to everything behind it. So I am going to foil these two first, the 2a plus 3 and the a plus 3. I'm going to foil that first and keep them in parentheses. And then the last step I'm going to do is distribute the negative so I don't screw things up. So this is 2a squared, and 2a plus 3 is 6a, and 3a plus 3a is, or times a. Talking to myself, guys, I hope you're keeping up. Okay, and now the next step I'm going to do is go ahead and combine my like terms here, the 6a and the 3a. So I'm just going to leave everything else exactly like it is for now. So 2a squared plus 9a plus 9 over my denominator. And you notice, hopefully, that between steps I'm skipping one line. If we don't do that, it makes it almost impossible to tell where one step ended and the next one begins. So please be sure to skip one line between steps. Now I'm going to go ahead and distribute this negative. So I've got 4a squared minus 8a. Negative times a positive is negative 2a. Negative times a positive is negative 9a. And negative times a positive is negative 9. All over a plus 3. A minus 8, and a minus 2. Now I'm going to combine like terms. So I've got 2a squareds here. So that's an addition problem whose signs are different. So I subtract the small number from the big number and keep the sign of the big number, in this case a positive. So these two are gone. Now I've got 2a terms here. So this is an addition problem whose signs are the same. So I add the numbers. Keep the sign. Okay, again, if you're not sure where I'm getting these rules from for adding and subtracting sign numbers, go look at my video on integers in the other helpful materials. And then the last thing I have here is 9. Okay, all by himself. Write my denominator. Don't ever take these things apart. Keep them together. Do each step in the numerator, step in the denominator, whatever you need to do, but keep them together. Now, I could be done, except I don't know if this is in reduced form. And the only way I can do that is if I factor my numerator. Well, 2 times 9 is 18, and so that's 1 and 18, 2 and 9, 3 and 6. I think it has to be this, which would have to be positive 1 and negative 17. And so now I'm going to stretch my middle term. Let's see, I'll do plus a minus 17a, excuse me, 18. I hope you guys caught that. 18a. Boy, that still looks like a 7. 18a and minus 9. I can factor an a out of those two. I get 2 plus a, 2a. Oh my goodness, must be time for me to go take a nap. 2a plus 1, and I'm going to factor a negative 9 out. That gives me 2a plus 1. And so now in factored form, my greatest common factor 2a plus 1, and I'm left with a minus 9. This isn't a difference of squares, however, because it's not a squared minus 9. And then a plus 3, this is my denominator, a minus 8, and a minus 2. So nothing I can cross cancel, so you can leave your answer either this way or this way. Just always keep in mind with these things, our numerator can stay in multiplied form or in factored form, but our denominator must always be in factored form. Don't ask me why. I've been trying to figure that out for years, probably decades now, and I still really don't know, but it's just a common thing that everybody in math knows. The denominator must stay in factored form. Okay? Now, once again, I highly recommend you watch this and then go watch the 3 in equations as well before you get started. Okay?